This class is being recorded because of some of us that will not be able to meet up. But I don't want to encourage that. I want everybody to also, for record purpose, we have to do that, one. And if you don't want your face to, if you don't want your video to be shown, you can off your video. It's allowed. Just listen to the chat. But if you feel comfortable with that, then if you are using your video, please make sure you sit where your network is very strong. Just kindly adjust your seat if you know that currently your seat is not that that place is not that strong. Please feel free to adjust your seat. According to the report, we have almost 400, I think 430 something that registered for this module or for this course. Then I want to beg everybody. I don't know about other classes, but don't miss linear algebra 2. And to start with, I want to know your degree, because some of us, I'm not too sure whether the number of the, if you are studying computer, please put computer. If you are studying mathematics on your chat box, please kindly engage there. Just type the name of your department or your degree. Put it there on the chat box. Let's quickly do that. Yes, computer science, Victor Ilori. Okay, HP, please, your name, you need to rename yourself, please. Rename yourself, your normal name. Make sure you retain your normal name. As you can see, my name, Shegun, okay. Okay, math and computer, information technology, okay. Information technology, yes. Okay, math and computer science, Amina, kindness, computer science, okay. Just feel free to supply all this information. It will help us so that by the time, because we're going to group ourselves and do some other stuff together, and which we're going to still present and do a lot of projects together. So yes, computer science, math and computer science. Okay, it's fine. I can see majority of us computer science, math, and computer information technology, they are common. If your department or your degree is different, please make sure you type it. Not because of me, because of everybody, so that at the end of the day, all of us will be able to have opportunity, to be able to communicate in a good manner. So please, if you are not talking, kindly mute yourself. If you are not talking, if I'm not calling you to say something, please mute yourself for us to enjoy the class. Mute yourself. And the rules of engagement in this case is, number one, okay, we have somebody in physics, okay. Physics, okay. Information technology, yeah, that's good. Yes. Now, some of us will be, I can call your name. Please don't feel shy. See it as a normal class. Feel free to express yourself. And at the end of the day, we all have so many things to, to fall back on. Okay, computer science. Okay, let me open my video so that you can see me too. Some of us, how many of us have watched the video, the introductory video that I put on your course page? Some of us are still asking me, where is the link? The link is already on your course page. The passcode is also on the course page. If you can log into your course page, there are links there that I've uploaded some video. Introductory video is there. Instructional video for this week is also there. Then I've solved some problems. They are also there. So after now, please, once you click that, it will take you to YouTube where you can download or you can make use of what is there. and listen to those, watch the way I solve some of the problem. We all know that mathematics is all about engaging. It's all about, I know some of you will be asking yourself, why am I doing linear algebra? After all, I'm doing information technology, right? That's the question. But I want to tell you, there is in the world of technology today, without linear algebra, without mathematics, you cannot survive. That is just the plain truth. Yes, some people might be saying, yes, after all, I don't need it for anything, I just need it for promotion, but you need to pass. It's part of the criteria. So I want to encourage you this morning. I know, how many of us, if you've downloaded your course material, please raise up your hand. Just use, just use your, yes, I can see, your e-hand or internet hand. Please, if you've downloaded it, raise up your hand very well. Yes, I can see, yes, I can see some people have downloaded it. Okay. You don't have access to, okay, some people don't have access. If you know you don't have access, kindly send a mail to those guys that are in charge, especially at NOU, at the non-headquarters. There are guys there that are technology guys there that will assist you. Yeah, 14 of us have downloaded it. Please, okay, I can see. Now, for those of us that have downloaded the material, hands down. If you know, please, let's raise up, let's lower our hand, lower your hand again. I will just call one or two people before we go into detail. Okay, who can tell us, how many of us you know that you've gone through the material and everything is superb, you understand everything there? If you know, if you know the material is interesting to study alone, raise up your hand. If you know it is interesting to study alone, okay, Idris Musa, can you unmute yourself? Unmute yourself, or do I need to do that for me? Okay. You can unmute yourself. We can't hear you. Okay. Oh yeah, you can talk now. Oh, sorry. Idris Musa. Unmute yourself from your side.
I've done that.
You've done that. Okay. Was it interesting? Okay, we can't hear you because of your internet.
Morning, sir.
Morning, okay.
Morning, sir.
Good morning, morning.
Yes, I actually downloaded the material, but the linear algebra thing is so abstract. And it needed somebody to guide me.
Okay. That's fine. Okay, let me call another person. Opayemi, over to you, sir. Was it interesting to go by it alone? You can unmute yourself.
Again.
Go ahead.
Yeah, sir.
Hello? Okay. Hello. Yes, now.
Yeah, it is interesting to go by it alone, but we still need the guardian.
Okay, sir. Okay. Okay, let me call and let me ask another lady, Debbie Okoro. Can you unmute yourself?
Yes, good morning, sir.
Good morning, ma. So tell us, do we need any assistance for this module or for this course? Can we read it alone?
Absolutely. Yes, so I'm not very good in math, so if I have someone to direct, like facilitate on this course, I'll be very happy.
Okay, that's good. I hope you guys will not be missing the class. Awa Garuba. Can you tell us, do you need anybody to guide you for this module, for this course? We can't hear you, please. Okay. Okay, let's quickly move on. As I said, every Saturday we will be having this course. Please, for those of us that we don't have access to the course code, to the course page, I will advise you try as much as possible to look for way how to get access to it. For some of those materials, I cannot be emailing to you. I have to be sending it, put it on the known platform, so that on the course page, so that anybody that missed the class will also have access to it. And I will strongly advise, please, I don't know about other courses, but I will advise you not to miss this. We all know the benefit of it. We all know that we need it to survive. If you want to go into coding, for those of us in technology now, you are studying computer science, you need it. If you are studying mathematics, physics, every aspect, where I'm going to group you, as I said, then I'm thinking of how many of us know about Telegram? I believe you all know about Telegram. How can we get access to the course page? I think you need to sign in into your page, into the NOUN, NOUN. When you sign into your page, I think all of us have a portal there. You have a student portal. Then from there, from student portal, you look for the linear algebra MTH 212. Okay, for those of us, Victor Ilori, are you there? Victor Ilori.
Yes, sir. Good morning, sir.
Good morning. So how do you access the your course page that you are able to download some of those materials? Can you say something so that others can learn?
Okay, I would there is a website, a link now, nou.edu2.net or something like that. I think I will copy the link and send it as a chat now, sir. Okay, sir.
Please do that, and others can also benefit from it. Okay. Like we rightly said, let us try as much as possible to be part of what is going on. Let me share my screen. Please kindly mute yourself if you know you are not the one talking, except if I called you to talk, so that we can all enjoy the class. Let me share my screen. Can you see my screen, please? If you can see, please say yes.
Yes, we can. I can see your screen.
You can see my screen. Okay. Okay. Thank you for that. But before now, I've explained go to your course material and try as much as possible to see how you can also be beneficial on the what is happening right now. So on the module alone itself, we have a lot of things to discuss, which I will also like us to concentrate on. So for those of us that have downloaded the material, we have something like this. Yes or no? Please, let's talk.
Yes.
Okay, okay. Now you will see something like this, and from then you'll be able to download them. I don't want to be reading the story. We all know the nature of the module. It's not storytelling, but nevertheless, I will still explain some of those key things we need to know. Please, this particular module needs your attention in the sense that you must learn the definitions. We have different definitions. For example, from the content, we only have 8 weeks of facilitation. And the part of the 8 weeks, I don't know how we are going to cover everything. Although I'm to facilitate. Facilitate means I'm to guide you by, okay, go and read this, read this, read this. But to me, there's no how I will still facilitate, I will not teach. You all know that. So if you look at this now, we have the unit 1. We have the content, which I believe you will read it after now, or you go and check the video after this particular class. So we have linear transformation. I'll start with linear transformation. This morning I've explained the video. Inside the video, please take your time and see what they mean by linear transformation. So let's move on. I solved some problems here, which it will also help us. They are all in that video, except if you have any question, that is when we go back to the video. But for now, after the class, please go to the video. So I will leave those ones that I've solved before, then concentrate on the latest one. So for us to cover up, like I said, we need to move on. So let's look at this. Then I gave us some idea to solve some of the problems on our own. Yes, there are solutions there, but don't copy solution for your own good. Try as much as possible. Don't deceive yourself. You can be saying, yes, let me deceive Dr. Okay. No, you don't need to, you can't deceive me. Oh, by the way, my name is Shegun, okay, as you can see from the my name on the Zoom link. So I will quickly solve 1 or 2 problems here, then before we call it a day. Okay, let's look at this problem. When we are talking about the space associated with linear transformation, we'll talk about the range space. By the way, who can tell us the vector space? What is vector space before we move to the linear space? Anybody? Yes, you can unmute and say something. Anybody? Daddy is in class, so.
I just know.
Go, I'm in class. Sorry.
Okay. Now, from the vector space, we all know that it's a group, it's a set whereby we're dealing with when you are dealing with sets, you know, so, okay, somebody raise up a hand. Eriata, okay, go ahead. Eri, can you unmute yourself? Okay, let's continue. Let me continue from there. We have, from here, we have what we call the range. What is the range in this context? The range in this context can be defined as is denoted by T. If the range is denoted by T and is denoted by T, and if the range is denoted by T, then our is denoted by this R of T. R of T means R, we know the R is range, whereby we use it to, that's why I said for this particular period, we will need to solve, we need to know the definitions before you solve. And this first chapter is very simple compared with the next things that we will be discussing. And I want to beg you so that you make it interesting. The question says, let U and V be vector space over a particular field. Let the T such that U map to V be a linear transformation. If you check up the definition on that, then for us to have the range of T as well as the kernel of T, the first thing you need to set up, we need to prove that these sets are also vector space over field. So then when we are talking about the range, I know majority of us, we are not interested in all these definitions. We only need to see differential equation or yx. No, there are basics you need to know. If I'm teaching someone in management now, they only need x 2 plus 3. But you that you are in science, you need to know the core things behind it. Now, for us to quickly move on, the definition for range of T is denoted by R of T, like I said, and is a set. Now, anytime you have a set, that's where you use the base. Please take note of that. So it's the same thing as when we have equals to the set sign and T of X. So such that at this point, we have it to be, can you please unmute yourself for those of us that are still unmute ourselves, please mute yourself. So that we can enjoy the class together. So at this point, what we need to do is, if you look at the definition, the first thing that needs to come to your mind is, which space are we talking about? Where are they moving to? Now, we have it to be X, such that our X belongs to, we know this symbol, the capital U. So in this place, but let me quickly solve this example. Let me look at the example here that I have in my own notes, and then we proceed from the example. You have idea of what we are saying. The first example here says, let's let our I such that our V map to the map to V. So from there we can say V map to map to V. B, identity. B, the identity. You have to manage this. You remember that we are working from B, the identity transformation. B, the identity transformation. Then the question says, find Ri, and that is rank of I, and the kernel of I, kernel I. So for us to solve this, that is why you need to go back and look for the definition of rank and kernel. Don't forget, from above, the course material and the video that I uploaded, I've explained the linear transformation, the definitions are there. So it's for your own good to take your time and see how to solve it. Then the solution for this will be the Ri equals to the I of V. This means such that small v belongs to capital V, which is equals to our small v such that the small v belongs to, sorry for the writing, let me try and write it again so that it will make more sense for you. So we have it to be our Ri, which is the rank we are trying to solve. We want to prove that this particular rank has identity. And if it has identity, we all know what it means in the matrix. If you don't know, we have a lot of metrics we are going to discuss in this course of this linear algebra. So please, by next class, let's try as much as possible to work on some of those problems in the course material, so that from there we'll be able to have a good idea of those things. So we are planning to, also plan to create a group whereby we can also have one-on-one a chat. I believe you will not misuse it. Now, what this thing is mean is our rank of I is equals to the I of V, which our definition from here, then which such that our small v is also belong to the capital of the family of capital B, V, which is the same thing as V equals to this, and at the end of the day, the definition says is equals to V. Then if you want to now, if you check the rank definition, you will know what I'm saying better. The rank, the range definition rather, you know what I'm saying is better. The range definition says that anytime you have the function of t of x, that is our x belongs to capital U, and it simply means the same t of x is the capital, we all define this as capital V, and here we have capital B. Then we can now move on. Also, we can define the same thing, have the same thing for kernel. Kernel I, which is the same thing as, sorry, which is the same thing as, let's look at the definition also. Small v in bracket belongs to capital V such that I of V is equals to 0. So I will advise you to check the kernel definition. You will know where is equals to 0. The kernel will always equals to, anytime you define the kernel, the same function, the same set links to volume. So which it simply means we have this V belongs to capital V such that our small v is equals to 0, which is the same thing as the set is equals to 0. So what we are saying in the sense that some of those things that we are dealing with, they are also part of the set. So it simply means you cannot do anything without definition in this case. Everything must be defined. You must follow the definition. Even if you check the video that I did, I also follow the definitions because everything must be defined from the set. But let's look at this. Number 2, it says that let's capital T such that the real space tends to this by divine by, now want to define this space, we have it to be T into x1, comma, s2, comma, x3, which is the same thing as 3x1 plus s2 plus 2x3. Then the question says, find R of t and kernel of t. So for us to find this, what are the things we need to do? Like I said the other time, the definitions. You have to go back to the definitions, and from the definitions you can do so many things from there. That the solution will be the R of t equals to x belongs to R such that there exists. This symbol means there exists. I believe you know it from Algebra 1, x1, comma, x2, comma, s3. So, which belongs to our real number with, don't forget your definition, 3x1 plus s2 plus 2x3, the same thing as x. So for us to solve this, like we are doing, I'm just trying to explain something that 0 belongs to R of t sorry. So 0 belongs to R of T since, based on our definition now, since 0 equals to 3 of 0 plus, that is our x in this case is 0. When you assume that the x is 0 here, what happened to the whole thing? Where you see x, you substitute 0 there. So it will make sense. So we have to be 0 plus 0 plus plus 0, then we have it to be 2 of 0. So at the end of the day, our t is 0, 0, 0. Then in a situation whereby your t, you substitute our x, we have x to be also, if your x is 1 over 3, is where we said our I belongs to re of t. Don't forget our I in this case, we can make to be the first x1, let x1 equals to 1 over 3. If you said our x1 to be 1 over 3, we have 3 into 1 all over 3 plus other remain 0, they are all 0. So here we have, at the end of the day, we now have it to be t into 1 all over 3. Don't forget, you said our x is 1 over 3, our s is 1 over 3, 0, 0, this. Then the question will be, if my s2, what happened to my s2? If my s2 is equals to 1, what happened? We have t.
Excuse me, sir. Excuse me, sir.
Yes, go ahead.
My name is Bolam. I think I don't know how true it is, but when you were solving for the 1 over 3, after calculating 3 brackets, 1 over 3, I guess that should be 1. So giving us 1, 0, 0. But I can see 1 over 3 there.
Yes. The question is, remember, we are not defining, we are only defining the definition of t. If you look at the definition from here, I think I defined it somewhere. Okay, look at what happened here. We are not saying the first t, we are not defining it as we are not using the issue of calculator now. We are just telling you at the t that what is the definition of my t x1, not the solution here. Mr. Ipaye, can you hear me?
Yes, sir.
We are just saying at this point of t, x1, what do we call it? We call it what? 1 over 3. That's why we place it 1 over 3 here. We are not defining I. Don't forget, it's not I. The total everything here is I. So we are just defining what is 1 over 3 is. Then in case if you check the course material, you see different definition per time. So that is what it's all about. Then you can also lay your hands on
Sorry.
Okay.
I think I'm sorry to bring you back.
Right.
Are we just assuming that S1 is 3, or there's a definition for this thing, for the equation that S1 is 3? My name is Boega.
Okay.
Sorry. Are we just assuming that S1 is 1 over 3, or there's a definition for it that S1 is 1 over 3?
Now, you remember there are space we are working on. We are working on the space of R3 from the definitions to R1. So we are just working based on assumption at that point. We just want to prove. That's why somebody raised it the other time that it's when he went through the manual, he discovered that it's abstract, which is true. You just working in abstract. You just pick invisible number. That okay, if I prove this one, if I put it inside this, what am I going to get? And don't forget, any number you pick from the real number, if I choose, I can choose another value. I can choose another, someone can also assume another value and put it inside, and at the end of the day, you arrive at the same thing because you are trying to prove. It's not that they ask you to press 2 multiplied by 3. No, we are not doing that now. Are you getting it?
Okay. Yeah, yeah. Also, sorry, one other thing is this place that's okay. Since this place you wrote since 0 equals to 3, sorry, move it more than the place. Okay, just a bit up. Okay. That is 0 such that 0 such that or subset of R of T. Since this one I'm seeing on the screen. It's
This one.
okay.
Okay.
Yes. 0 is subset of R of R of T since 0 equals to. So I don't know how is it also abstract. This 0 equals to 3 of 0 plus 0.
Remember, it's supposed to be, this is X. This particular one, let me just identify it for you.
Okay.
Let me highlight it. This particular one, right? From the definition here is X.
Okay.
And from here, we know that our everything below equals to X. Now, if you are not saying my X is equals to 0, it's still subset of the O set, right? Then anywhere I see this, substitute 0. Then at the end of the day, I'm going to have the transformation. Please, you guys need to go and watch the video so that you will know the basic. I don't want to repeat myself from the video. I'm still beginning to explain because I believe everybody has watched the video because they have been uploaded on your platform, on your coursework. So on your course page. If you don't have access to course page, please ask people that have access to course page. The videos are there. Then on the YouTube, you can also subscribe to that YouTube. In case I send anything on the YouTube, you have alerts because I upload it on the YouTube. So you have alerts on your YouTube channel or on your phone that, oh, Dr. Oke has uploaded things. So you quickly go and watch it. You can access it through your course page or through my YouTube channel so that it will help you and it will, lower the expenses that you are going to be spending on this. So you can look for if you check, what do they call it? Remember, we have different, in your course material, you can look at you can complete this book, it's there. And from then, when you complete it, you will know what we are trying to say. In case, if I want to complete this one, if I said, okay, remember I assume this one to be 3, I can say my S2 is 1. If my S2 is 1, what happened? My S2 is 1, I will have I to be equals to 3. Others will remain 0, 1 plus 2 of 0. Remember? So then our transformation here will be T into 0, 1, 0. Then if I still go ahead and assume other value to other, let's say my S3, I want my S3 to be 1/2. If my S3 is 1/2, it simply means my T at this point will be 0, 0, 1/2. So please, let's take note of that and so on and so forth. So for the kernel, can explain the kernel too. Based on the definition of the kernel, let's say kernel T is the same thing as x1, s2, s3. So, which belongs to the space of 3, such that 3x1 plus x2 plus 2s3 equals to 0. So at this stage now, if I substitute if you apply the same example from the example that, okay, 0, 0, 0, they all belongs to the kernel of T. But if I try to say that 1, 0, 0 also belongs to, if I said belongs to kernel T, so, sorry.
It's okay, we can see it. I can see it too. I can understand what you're writing.
Okay,
I don't
any
think
question?
there's no point raising it, no?
Now,
Alright.
oh, sorry for those writing, and you all know that at this point, we cannot agree that our kernel of T are not the same thing as R of 3. In fact, the kernel of T is plain because of the R of T, the plane we are working with. But we have series of examples and activities on the course material. I want you guys to lay your hands on some of them. And if you need more clarification on that, you can send a mail to me. I believe some of us got my mail, but some mails are not, some people don't have a good email to work with. But lastly, I will quickly put this one on board. Then I want everybody to try as much as possible to do it on their own. When you set let T such that the plane 3 is moved to the R3, we are working on the space of R3 by divine by T of x1, x2, s3. So they defined this particular one too by saying that it's the same thing as x1 minus x2 plus 2 of x3, comma, let's say, and then 2x1 plus x2, another space. Then we have here minus x1 we have minus x1 minus 2 of x2 plus 2 of x3. Yeah, there are some topographical error in some of the material that might not be too that clear. So, but I will try as much as possible to make justice to some of them here. So here, if you can find our range T of T, then kernel T. So for us to find it, you have to define this particular question leads to simultaneous equation. How do we solve it? I believe some of us still remember the simultaneous equation. Then we can lay our hands on it. Then I can just lay a simple foundation for us to be able to solve the simultaneously. Any question? Somebody raising up the hands? Frederick Boyega, are you still raising up your hands?
Yes, thank you very much. I think this equation. Are you asking us to solve this one? This particular one you just
Yeah,
wrote right on the this,
yes, you can solve it, or if you want me to explain further, I can also do that.
Okay. Let me try. I will try.
Okay, Idris Musa. Yes.
Yeah, I just have a little confusion in the solution we just finished,
Okay.
where we have 1/3. Are we saying that x1 is equals to 1/3?
Exactly. That's what we are saying. Not x1 equals to 1. We are not multiplying it. We are just defining the x1 in the space of x1. And the first one is 0, as the whole s is 0. Then what about when you define them one after the other? x1, x2, s3. Then it will show from the range of t.
Okay, thank you very much, sir.
You're welcome. Okay. Any other question? Okay. Do we need, okay, maybe I should lay the foundation of this one so that before we call it a day. So it says that the solution is quite simple. The solution is quite simple. So for us to find, we must find the condition on, to find the RT, we need to find the condition on, let's say, our Y1, comma, Y2, comma, Y3. They all belongs to the real number. And so if they belong to the R, then we can say that our Y1, Y2, Y3 belongs to the range, the RT. Sorry, let me do this. Belong to the RT. So we can also find the, we must also find for the X, this is for Y. If I want to find for the X, I can say that my X is X1, comma, X2, comma, S3. They also belongs to this particular field, so that by the time we define them one after the other, we can say that by the time we define them, we can say our Y1, comma, Y2, comma, Y3, they all equal to T into X1, S2, and S3. Don't forget, you already defined them all. They are all here. You have it. Let's say this is X1, this is X2, and this is X3. Let's take note of that. So from there, it will help us by saying that everything equals to everything now equals to X1 minus S2 plus 2S3. Then you have 2X1 plus X1 plus X1. Then we have it to be minus 2X1 minus 2S2 rather, plus 2S3. So it simply means that I can now put this in the equation by saying the first one will be x1 minus x2 plus 2s3 equals to y1, equation 1. So I can define others too and define the third one also by saying 2s1, yes.
You missed one of the minus x1 there.
Oh, yes, I will put it when I'm writing the equation. Thank you. Equals to y2, then equation 2. Then you can also say minus x1, I think you're talking about this, minus 2x2 plus 2s3, and
Yes,
this
sir, that
is
is the one.
y3. y3, which is equation 3. Then you can go ahead and solve this so that you can go ahead and solve all this and get some of those some of our parameters out. So from then you will discover that, please, I want to employ you to make sure you finish this before the next class, so that by the time you finish all this one, look at the memory, look at the definitions that I gave you. Please work on it. Some of those linear function, linear transformation, types of linear transformation, when is subjective, one-on-one, injective. I will try and see if I can make 1 or 2 videos concerning it, so that before we move to isomorphism, homomorphism, invertible metrics, before we move into that, because we need to show some of those things very well. Please, it is important and it is compulsory. So remember, I'm not teaching, I'm just facilitating. And there's no how you facilitate that you will not teach. Let me stop sharing my screen. So I would like to hear the feedback from you guys. Hello. Yes, Idris Musa. You raise up your hands.
Okay, yeah, I raised up my hand. Then when I was telling you about the minus x1,
oh, okay.
I forgot to lower it down. Let me do it right now. Thank you, sir.
You're welcome, sir. So for this course now, I think it's good for us to have what do we call it? The WhatsApp page, whereby we can also communicate and have one-on-one. I believe, or is it not? Is it necessary or not? If you think it's necessary,
it's necessary, sir. Let's use Telegram, sir.
We should use. We are more than 256. I think we can use
Telegram.
We can use Telegram for that, right? How many of us have,
Telegram will be better. So people can always come there and see the information. Right?
Telegram will be better, sir. Yes, sir.
Okay.
Please, let's use WhatsApp, please.
Wait. No. Anyone, majority will carry the vote.
So Telegram, please.
Telegram.
Okay. If you want Telegram,
WhatsApp.
type it. If you want WhatsApp, type it on the chat.
Okay, sir. Okay.
Please mute yourself. Mute yourself. Mute yourself.
Nana. Come. Zona. Come.
Just make sure you mute yourself once you are not talking, except if I call you to talk, then, or else I will mute you from. Okay, we have Telegram, we have WhatsApp, we have Telegram, we have WhatsApp. Telegram is not bad, WhatsApp is not bad, but we all need to be considerate at this stage. Remember that when it comes to Telegram, we only have, when it comes to WhatsApp rather, we have a limited space. But when it comes to Telegram, it can accommodate more than 10,000 people. So if you don't have Telegram on your phone, I would advise you download Telegram. Yes, Victor, you can talk.
Yes, sir. I think Telegram will be better, even apart from accommodating others, sir. Those who are newly joining will be able to see what has been posted earlier, and that would reduce distraction from repeating what has been said before, sir.
Okay. So I think we'll go for Telegram. Then if you don't have Telegram, please, you can download it on your Play Store. Or if you don't have a good phone, please, this is technology area that I think we all need. I will advise you to look for a good phone and always check your course page. It's for your own good. Remember, you are the one that need a degree. So do yourself a favor by visiting the course page. Look at the due video, share on that page, and quickly work on that. Any other question again? How many of us got my email? If you got my mail, please raise up your hand. If you don't get it, raise up, let us know. Okay, yes. Okay, if you get, yeah, I can see a good number of us got the mail, correct, fine. So, what summary do you want, Moses? The summary is you will get the link. I will share the link with you on the, maybe I'll send the Telegram link on your email or thereabout. I don't know yet, but you will get the Telegram maybe on your course page. Please, is it on your course page? I will try and see how to communicate it with you guys. Any other thing? So my name remains Shegun. Okay. Thank you for coming. Then make sure you retain the same link. Don't ask for me any other link next class. The same link will continue to be using throughout the whole section. Please take note of that. Thank you. If you don't have any other question, please, mathematics and computer students who have been able to register. So if you don't have any other things, or if you have any other questions, let me know. Thanks for joining. See you next time. Much. You're welcome, ma'am. Thank you.
Thank you, sir.
Thank you very much.
I hope you enjoyed the class.
Yes, sir.
Okay.
Yeah,
Thank you very much, sir.
Thank you, sir.
Thank you. You're welcome.
Thank you, sir.
All right, sir.
Thank you very much.
Bye.
Bye.
Thank you, sir.
See you next class, sir.
Bye.
See you guys.
All right, sir. Thank you.
Thank you, sir. Bye.
Bye. Thanks for coming.